Now, today we are going to discuss about the friction on vertical plane. So, friction on vertical plane I am going to discuss. So, you can see here, already we discussed friction on horizontal plane and black on black. So, once again, horizontal plane and some other problems I will do. So, it's coming into here in vertical plane. So, black is pressed against the vertical plane by force amount of force F. That means, so the mg is the driving force here. So, mg is driving force, which is cause for the motion of the black. Driving force. But whereas friction F is the applied force is normal and friction is which is equal to upward motion, which is balancing this. So F is equal to mg. So now F is equal to, we know, mu into n. So here mu into applied force. So that equal to mg. So now F is equal to mg by mu. So this applied force sometimes ma. This applied force which is equal to ma. So that means when the plane, vertical plane, for example, this is the plane, car, bus something of mass m, having the acceleration here like this. So here there is a one block of mass m attached to this vertical plane. So this mass can be phi also. The same concept here. So there is a friction upward direction and mg is driving force. Because of this acceleration, there is no applied force on m. Even though this block is at rest, it is stick to the car. That means, so here F is equal to mg again. So that implies, so here F is equal to mu into n. So n is pseudo force. So mass of this one into acceleration of this one in opposite direction. So that is equal to mg is equal to F equal to mg. Mu into ma is equal to mg. Invert cancel, then a is equal to g by mu. So in vertical plane, remember a is equal to g by mu. For a, the plane, vertical plane, which is moving in one direction with acceleration a. So vertical plane rest and a block is pressed against with force F. Then F is equal to mg by mu. And here this F can be ma. So this I have given. Similarly, in this small example, so one person. So let one person is so hiding in chimney of house. He is thief. So by pressing the wall with his hands, the force F. So this is normal force. Is applying force F. So only he is holding or he is stable in rest by pressing both the hands against the wall. Then normal force is F here like this. If he is pressed with the legs also means, so then here F. Here also F. So only pressing with the hands means 2 into mu into F. The friction force is here. The friction force is here F. Here also F. So welcome back. So welcome back, guys. Now today we are going to discuss about the friction on vertical plane. So friction on vertical plane I am going to discuss. So you can see here, already we discussed friction on horizontal plane and black on black. So once again, horizontal plane and some other problems I will do. So it's coming into here in vertical plane. So black is pressed against the vertical plane by force amount of force F. That means, so the mg is the driving force here. So mg is driving force, which is cause for the motion of the black. Driving force. But whereas friction F is the applied force is normal and friction is which is equal to upward motion, which is balancing this. So F is equal to mg. So now F is equal to, mu into N. So here mu into applied force. So that equal to mg. So now F is equal to mg by mu. So this applied force sometimes ma. This applied force which is equal to ma. So that means when the plane, vertical plane, for example, this is the plane, car, burst something of mass m, having the acceleration a like this. So here there is a one block of mass m attached to this vertical plane. So this mass can be phi also. The same concept here. So there is a friction upward direction and mg is driving force. Because of this acceleration, there is no applied force on m. Even though this block is at rest, it is stick to the car. That means, so here F is equal to mg again. So that implies, so here F is equal to mu into n. So n is pseudo force. So mass of this one into acceleration of this one in opposite direction. So that is equal to mg is equal to F equal to mg. Mu into ma is equal to mg. Get cancel. Then a is equal to g by mu. So in vertical plane, remember a is equal to g by mu. For a, the plane, vertical plane which is moving in one direction with acceleration a. So vertical plane rest and a block is pressed against with force F. Then F is equal to mg by mu. And here this F can be ma. So this I have given. Similarly, in this small example, so one person. So let one person is so hiding in chimney of house. He is thief. So by pressing the wall with his hands, the force F. So this is normal force. Is applying force F. So only is holding or is stable in rest by applying the by pressing both the hands against the wall. Then normal force is F here like this. If he is pressed with the legs also means, so then here F is also F. So only pressing with the hands means 2 into mu into F. The friction force is here. The friction force is here F. Here also F. Now acceleration is moving upwards. So that means this is the maximum force giving in upward direction. So F maximum, F sin theta. When it is moving upwards, mg and F sin theta downward means F is downwards. Therefore, F sin theta is less than or equal to mg plus mu into F cos theta. So this force is now giving the acceleration upward direction, F sin theta. So to give the acceleration upward direction, the maximum force I need to apply this much. F sin theta, which is applying on upward direction, giving the acceleration should be less than or equal to mg plus mu F cos theta. Therefore, F sin theta will come this side. F sin theta minus mu cos theta is equal to mg, less than or equal to mg. That means F maximum. This force is maximum to make move upwards. That is equal to mg by sin theta minus mu cos theta. The denominator minus the fraction is maximum. Similarly, now let A is means tendency to move downwards. Tendency to move downwards. So in that case, F sin theta means mg minus F sin theta. Otherwise, F sin theta plus F is equal to mg. So then it will move downwards. So now here F is equal to So now F into sin theta plus mu cos theta is equal to mg, less than or equal to mg. It means actually driving force is equal to mg minus f sin theta when it is moving downwards. So which is equal to ma. So this is the driving force. Here also f sin theta minus mg is the driving force when it is moving upwards. F sin theta minus mg is driving force. Means cause for motion, getting the acceleration. So now here the f value is equal to, so this is minimum value, f value is less than the minimum value of f, less than or equal to mg by sin theta plus mu cos. So this is two formulas for f maximum and minimum. So here this f sin theta plus f greater than or equal to, greater than or equal to, greater than or equal. So now the force which is applying on the block with angle theta, the lies between. So this will be force is less than or equal to, the force is less than or equal to mg by sin theta minus mu cos theta, and it is greater than or equal to mg by sin theta plus mu cos theta. So this is the f value required to move upward or downward. The force required to move upward acceleration is f maxima. The force preventing to slide down is f minimum. This is the f value lie between these two values, maxima and minimum. Finding the magnitude of frictional force in vertical wall direction. So friction against vertical wall. So remember here, when force is applying perpendicular to the wall, then frictional force is equal to mg, which is equal to mu into f. So now here you have to determine the frictional force. Mu into f is, mu into f is static, maximum static friction, FL, limiting friction. So now is asking FA, static friction. So that equal to mg when in the case of mu f is less than or equal to mg. If mu f is greater than or equal to mg, it will become fk. So now this point remember. So mu f is maximum static friction and f equal to mg is the static friction, applied force. Mg is the applied force, not f. Here f is applied against vertical, but mg is always downwards, which is driving force. So mg is more means it will move down than mu into f. Mg is less means it will be in static. Therefore, static friction is equal to mg always, applied force. So remember this point. So now coming into this example, here 100 newtons and coefficient of friction is 0.2. FL is equal to mu into 20 newton and mg is equal to 50 newtons. So here mg is greater value. Means motion, the block is moving downward direction. So therefore static friction is equal to limiting friction. So once again I am telling static friction is equal to limiting friction when it is moving. When block is moving downwards or upwards, it has a kinetic friction only. Static friction is asking means maximum limiting friction. So whereas limiting friction is more than mg. So here next example, see. So here mu into n, the limiting friction is 100 newtons, which is greater than mu f is greater than or equal to mg. So then mg is called static friction. So applied force on this block in this case is 50 newtons only, mg only. So this is a normal force which gives the maximum static friction. So now here FL is equal to static friction is equal to 50 newtons because it is not moving, right? Because of more mu f value, maximum static friction. Similarly here f sin theta is there. So calculate f sin theta. So f sin theta is equal to 50 newtons. So here f sin theta in this case 50 newtons. Mg is also 50 newtons. So therefore driving force is equal to, so driving force is f sin theta minus mg. This is called driving force. Driving force means which is responsible to the motion, either upward or downward. Okay, F sin theta is maximum, it will move upwards. F sin theta is minimum, it will move, means F is maximum, it will move upwards. F is minimum, it will move downwards. So now frictional force means F sin theta minus mg is equal to 0. That means driving force 0 means frictional force is 0 here. Applied force is 0. Driving force is 0 in this case. So when force applied in incline, you have to find out the driving force. The force applied vertical to the wall. So then you have to find out maximum static friction and the mg. In this vertical wall case, force applied perpendicular to the wall, then it depends on mu of value, maximum static friction or limiting friction. Mg is equal to static friction will come. Another example. So he is asking to find out friction. So find out F sin theta value is equal to 100 into sin 37. That means 3 by 5. So 60 newtons. So F sin theta. Mg is 30 newtons. So maximum static friction means Fl is equal to, so here mu is equal to 1 by 4. Here given mu is equal to 1 by 4. 0.25 means 1 by 4 into F cos 37. That equal to 100 into 4 by 5. So that equal to Fl equal to 20 newtons. So now this Fl will act, means F sin theta is 60 newtons. Fl is 20 newtons according to given. So now static friction will be, means it will not move, right? Because F sin theta is more than 30 plus 20, 50 downwards. It have a upward acceleration. So now mg is the static friction. So it is in the motion. So when it is in the motion, already in previously we discussed that. So mg is the static friction, applied force mg. Therefore, frictional force is equal to, static friction is equal to 30 newtons, not Fl here. So Fl and F sin theta here decides it will move upward or downwards. So another example now. Coming into here, this question. First, I will explain some means concept here. Then we can see this values you can substitute. So when this force is acting on the block, it is not moving means there is a pseudo force, normal force acting on this mass. There is a pseudo force. So that is which is equal to, so A is ma. So normal force is equal to here ma. So which is equal to, so m into F by total mass. So m plus m. So not, that is not equal to F here. Mf by m plus m is the normal force on smaller block. So then this normal force is acting on the block when in the case of accelerating frame. So it is not moving means this block is not slipping against this ball. And here you can see, so this maximum acceleration will be, so here find out ma how much will come. So now acceleration is rightwards, therefore m plus m into a is equal to f minus, actually fk has to come, but here mu is not mentioned, it is k or s. So that is equal to mu into m plus m into g. So now this is condition for getting acceleration. Acceleration is formula. So now this is not moving down because this is the condition. Here this is the condition when friction is not there here between the ground and floor. So this is A is equal to F minus mu into m plus m into g by m plus m is the condition when friction is given. So acceleration, finding acceleration. So now this acceleration is act like a slow force ma now. So here ma. So here ma, in this case ma is equal to m into F minus mu of, so this is m plus m into F minus mu m plus m into g by m plus m is the normal force. So which is into mu is equal to mg. So then it is not slide, right? It is asking for not slipping only. So where mg is equal to mu into this ma, normal force. So this m and this m get cancelled. So now apply these values. So you will get, so 100, F is equal to 100 minus Mu we are going to find out. Mu into 4g is equal into mu again. So into mu is equal to 4 into gml. So that implies, so mu square 4g plus 100 into mu plus 4g. Mu square into 4g minus. So this mu square into 4g, I'm bringing this side 4g. So 40 40 there. So is equal to 0. So now this solving, we'll get like this. See. So one quadratic equation is coming. So 4g take common means 44g. Mu square minus 2.5 mu plus 1 is equal to 0. So now 2.5 plus or minus root over 2.5 whole square minus 4ac4 by 2a, 2 into 1. So that equal to 2.5. So this is plus or minus root over 2.25 by 2. So that equal to 2.5. So friction for minimum, this is minus only, I will take by 2. So that equal to 0. So 1 by 2, 0.5. If you take here plus, it will be more than 2, means equal to 2 will come. So generally the minimum friction only is asking. So this is. So next, coming to next example. Now another example. So here it is diametrically appearing somewhat difficult. So after seeing the given points, and free body diagram will be easy. Check once. So C is placed on frictionless surface. So here this is smooth. And capital M and small m are connected. The help of pulley and massless strings. So tension is same here. And both the blocks have friction is mu. So here it is mu. So here also it is mu. Find the acceleration of block C. So the block, how much acceleration it has to move in rightwards to keep M and M are rest. So now see. So take the free body diagram. Means because of this acceleration, so there is a normal force on the pseudo direction, normal force on these two blocks MA. So on small m only normal force is active. So consider free body diagram of M and capital M. So here, this is important here. So for M block, so which is acting tension, means here given condition they are not moving. That means T is the maximum value here. So T is maximum means the friction force should act downwards. That equal to T is maximum means mg plus F1. mg plus F1 that equal to mu here. Coming into capital M free body diagram. So here F1 is act on small m or capital M upward direction. Friction also upward direction. mg is downward direction. So now write the free body diagram. T plus T is equal to this T is equal to T plus F1 plus F2 is equal to mg. So now T is equal to capital mg minus F2 is equal to the friction, static friction between C and capital M. That will be mu into m plus m of A. Here plus F1 also there, that equal to mu into ma. So bring this here in the place of T, I can write mg plus mu ma. The place of T from equation 1 I am substituting here mg plus mu ma. So here small m only this is equal to, this is capital M minus mu into, here you can see here ma is there, mu ma, and here also mu ma is there, therefore capital M plus 2m into A. Now A terms one side, G terms one side, we'll get answer like this. So this is acceleration. For example, these two are same masses now. Suppose these two are same mass. So let here apply same mass, m minus m. So 0. So for acceleration is equal to, so 0. Both are equal masses means, so here C no need to be in a motion, they will be in a equilibrium only. So this is another example. Next example, and all these example, the block which is against the wedge are against the wall is not moving, is not slipping. So that you have to remember. So if you see this diagram, is asking to find mu minimum. So when we will get mu minima and mu maxima, so with another example, last example I will explain. So he's asking mu minima. Find that. So write the free body diagram automatically, and the condition is equilibrium. It is not moving. And if you see diagram, there is a coefficient of friction between 2m and ground also, and there is smooth between m and 2m. Then you can give here mu also, no problem. He's asking mu minima between ground and 2m. So free body diagram, if you apply 2t here, this is the t, and here also t. 2t is equal to mu into the total mass 3m into g. And for this small block, t equal to mg. For small block, t is equal to mg. Because equilibrium means t is equal to mg. And for this system, m and 2m, 2t and frictional force this direction. 2t is equal to, because it's not accelerating, equilibrium is not acceleration, mu into 3mg. So now we will get mu is equal to 2 by 3. Similarly here, so vertical wall, capital M is there, small m is there. Between this one and this one means capital M and small m, mu is equal to 0. Between ground and capital M is 0.25, that equal to 1 by 4. Asking the ratio of m by m. So now, and system is given in the equilibrium. Apply the free body diagram, T equal to mg for small block, and capital block, apply the free body diagram as previously. So now we will get 3 is equal to capital M by small m, and small m by capital M is equal to 1 by 3. This is the ratio of asked question. M by m means 3, small m by capital M means 1 by 3. So remember. So very easy this and all. So next application. So coming into next application, in this example, the similar like above, but here between ground and small m and means capital M you can go, and small m sometimes you can apply. So first we will go with capital M, and in the capital M plus small m also will substitute. Both are equal masses means. No need to worry in this case. This is very big block and this is very small block. Then how it is capital M, small m, and this is also small m. It should be capital M only. No need to worry in that case. Different materials can have. Size more means no need to be mass more. Condition, you can take cases. Okay, we'll go with capital M here. And here this is M1. Need to find out M1. So conditions are given here. What is the M1? To keep M is not to slip. And here mu2 can be greater than 1 also is given. We will check once. What this condition is given, why this condition is given. So if you see the diagram. So now consider this system because of this suspended mass having acceleration here downwards. So now this whole system also having acceleration rightwards. Write the free body diagram. So m1 into a, first I will write for this one, m1 into a is equal to, so m1 into g minus t. So this is free body diagram for m1, FBD for m1. Similarly for this one, free body diagram, m plus small m into a, rightward direction. So that is equal to t minus mu into m plus m into g. So this is equation. And we know we can substitute the t value here. In this case, 1 into that equal to m plus m into a is equal to t is equal to, so this is capital M1 means what I am going to find out, m1 into g minus m1 into a. So m1 I want to find out minus mu into capital M plus small m into g. Here while you are writing capital M, small m and m1, so everything you have to write. Otherwise one place instead of something you are taking, it will be a whole question will be missed. So we will go wrong. That's why I am going slowly here. And here condition is given. What the condition means, it is not slipping, right? So that means F2 is equal to mg. So here the force, that means ma. So pseudo acceleration on this mass, thermal force. So small m into A. So here acceleration is same everywhere. So small m into A into mu, normal force into mu is equal to small m into G. So I got, sorry, m get cancelled. Mu is equal to G by A, or A is equal to G by mu. You can substitute. I want m1. So what I will do for getting m1? So m plus m into, so in the place of A I can write G by mu. So A I no need to need G by mu plus mu into m plus m of G. So which is equal to, so given m1 into G minus A is equal again G by mu. So now that implies, so I want m1 only. I want m1. So now G by mu. So this will come this direction. Capital M. So here also mg into mu, right? So mu capital M into G. Here capital M take common. Capital mg take common. So here 1 by mu plus mu is here. Similarly, otherwise you can go with capital M plus small m take common. Capital M plus small m take common, better that is. So if you take capital M plus small m, G by mu plus mu G. So G also take common. Okay, next step I will see. So that equal to here m1 of 1 minus 1 by mu. So now G and here G get cancelled. So now that implies m plus m into. So here see both are, I have taken here mu's. Mu are same. But in the question given see mu1 and mu2. So here where m1 plus m2 are taken, it is mu1. So here it is mu1. And here it is mu2. So this is mu2. So mu2, here it is mu2. Now denominator is mu2, this is mu1. So here it is mu2. Mu2. So mu2. Means mu A equal G by mu2, right? This is mu1. Otherwise you can give mu only, but in the question they mentioned mu1 and mu2, you can go like that. So concept is same only here. So that equal to 1 plus mu1 mu2. So denominator mu2 will come, here also mu2 get cancelled by, so mu2 minus 1. mu2 minus 1. That equal to m1. Now I hope you understand why they mentioned here mu2 is greater than 1. If it is less than 1, what happens? m1 will be, mass can be, here negative is coming, right? But mass never be negative. This is a very good state. Time and mass never be negatives. So mu2 compulsory here greater than 1. They are not equal to 1 also. So this is the condition that I mentioned. So now for suppose these two blocks are same mass. So then that is equal to 2m into 1 plus mu1 mu2 by mu2 minus 1 is equal to m1. Both are same mu's. So that equal to 2m, same mass and same mu, same coefficient of friction. Then 1 plus mu square by mu minus 1. So that equal to m1. And here mu is not less than, not equal to 1. And less than, not equal to, less than or equal to 1. If it is equal to 1, mass will be 0, not possible. If less than 1, the negative mass cannot be negative. So this is. So next, coming into another example, asking to determine the force when black not to slip. Determine the force. So here see, the same black is right hand side, then F equal to MA can apply. But here F is left hand side. So that means take the free body diagram of M now. So there is a friction, there is mg downwards, and applied force perpendicular to the wall, or this is moving card, and there is a MA. MA. So if you write now, Friction is equal to mg. It is not slipping, right? Not to slip. Then friction equal to mg. So your friction equal to mu into, so normal force, that equal to F minus ma is equal to mg. And the A can be F by m plus m, right? So A is F by m plus m. For mu into means common acceleration here, A is equal to, according to given force, F by total force by total mass, capital M minus m. That equal to mu into F minus small m into F by m plus m, that equal to small m into g. So now that implies, so here small m into f and small m into f get cancelled. Mu into capital M into f by m plus m is equal to mg. So he's asking to find out, determine the force, right? Force. That implies F is equal to mg by mu into m plus, so m by capital M. So that I can write mg by mu, m by mu I can write, otherwise mg by mu into 1 plus small m by capital M. So values are given means you can substitute. So I hope this understand. Similarly, next example and last one on the vertical surface. Two more models are there, but I have no time. So I'll give finally overall some problems. In that I can cover that models. So again, as two blocks are pressed, the type of models I forgot to take here. Time also not there right now. See, the floor and bigger block have no friction according to given. The mu is the friction between two blocks. Block to block. Here is a mu. The here also mu. And condition, they're asking A value. So A is equal to F by applied force by total mass, that equal to m plus 2m. This is very simple. So now is asking to find out A minima and A maxima. So when now this one can have the acceleration downwards, then this one have acceleration. It is downwards means this is acceleration. Also like this has to come. Then friction is acting in the direction, opposite direction. So this friction opposing the acceleration. So now this acceleration is called, means here, if you see, when will be A is maxima and when will be A is minima. As we discussed in the first example, when T minus mg is the driving force here. So now downward acceleration means F is minimum force. That means A is minima. Then A is minima. In the case of A minima, the acceleration is downwards. That means T plus F is equal to mg. Equation 1. And similarly here, for this block also apply same. So T minus F is equal to, so here the F is ma. Mu into n. So that equal to mu into, so here in the first equation F is equal to mu into n. So that equal to mu into ma will come. So this acceleration is different, and this means the system acceleration, it is moving, this m plus m is moving horizontally. There is a pseudo acceleration will act like this, that equal to this is normal force, which is given normal force is A, and here A, ma. This A and this A are equal. So now this F is equal to mu mg here. So the F on horizontal surface is equal to mu mg. So this is F on vertical surface, this is horizontal surface, this is vertical surface. You should clear, we can't cancel these two. So now T plus mu ma is equal to mg, and T minus mu mg is equal to ma. So now subtract. So these cancel. Mu ma plus ma, this ma minus ma is coming this side, is equal to mg minus mu mg. I want A minima. This is A minima. Therefore, A minima is equal to mg take common 1 minus mu by, so here m into 1 plus mu. So mm get cancelled. So that equal to A minima is equal to, so 1 minus mu by 1 plus. So automatically we'll get A maximum. Means here denominator maximum means fraction will be less. That is minimum. So A maximum means the driving force will be upwards. That means acceleration upward. F sin theta minus mg. Then friction will be downwards. Therefore, F sin theta is equal to mg. Already we have taken in the first example. So now similarly here A maxima will become 1 plus mu by 1 minus mu. And now the F lies between means F maxima and F minima. So we know F maxima means F sin theta minus mg is less than or equal to F. And minima means, for minimum force means mg minus F sin theta is less than or equal to F. This F between, so here between the capital M and small m, which is suspended here, not on the horizontal surface. So in first examples I have given. So F maxima, driving force is maximum means F sin theta minus mg, driving force less than or equal to F. That means it is moving upwards. So maximum force, and moving downwards, the acceleration is upwards, force is maximum, acceleration is downwards, force is minimum. This point remember. So now we know it will be lies between 1 minus mu by 1 plus mu into m. M means what? M plus 2m. Then this value means A minima into mass. More, it will be less and force is more. So this is maximum force when it is downwards, A minima. Less than or equal to m plus 2m into 1 plus mu by 1 minus mu. So maximum force. This is maximum, this is minimum. Maximum is accelerating upwards, minimum is accelerating downwards. This you have to remember. Already driving force I have given in the first example. So here you will get clarity. So this is about friction on vertical surfaces and combination on wedges. So with some other models, I will come finally after inclination and horizontal surface. Thank you. Namaste everybody.